Hey everybody, this is Rashid. Hope you're all well. Um, Today I'm recording a video about transistor scaling. It's a question everybody asks me that, okay, what is a process node, what is a technology node, and how it's scaled. Um, this is very interesting topic. I did a while back, many years ago, quite a bit of research on this, how things scale from say 0.350 micron all the way down to 10 nanometer. Okay. So yeah, if you take a look at this was the slide I created a while back. I look at all the IEEE papers from Intel, and what were the details of each process node. So for example, this is where I started. This is 350 nanometer or 0.350 micron. And then I started seeing, okay, every 2 years, Intel came up with the publication of another node. Now all this information is available to public and published in IEEE papers, so it's nothing confidential here. I mean, I work for Intel, but there's nothing confidential here. Um, and it was so interesting for me to see how every year they were able to scale every 2 years. Now, even when things were here, um, you know, you could hear, oh, yes, this is not going further down would be very difficult. There are too many problems. What would they call it? I don't know what was the terminology used. Yeah, this was all submicron, right? Because less than 1 micron. But all the skepticism around, there is no way you can go further down. And it's amazing how engineers and scientists are able to find a way of making these transistors smaller and smaller. This is such an amazing story, and I think it would be good we go through this together and see what kind of engineering innovations or technology innovations um, people have come up with and how they went from one technology node to another technology node. So I will do several think video sessions for that, and I think it will be very interesting. So first question is, you all know that, okay, we typically call this Moore's law because Moore from Intel, a while back he predicted that every 2 years transistors will double. Okay, so is Intel doing it because one of its um, scientists or engineers said that will double? Is that the reason? No, I think Moore's law is more of an economical law, right? Because that shrinking, that scaling favors um, the cost. Okay, and that's where we want to do scaling. Every 2 years, if the number of transistors double, okay, then we can add more functionality um, in the same area. So if this one area and it had like 1 million transistors, now 2 years later in the same area we can add 2 million transistors. Then that means that we can put more functionality, more features on the chip. And by adding more features, we can um, bring some new thing for the customer, and we can charge that, um, because now we're bringing some new cool things to the customer. So, that's really the, I think, the basic point of that scaling. Um, our price points are typically the same. So every 2 years, we are adding more functionality. But there was also another drive of increasing the clock frequency, increasing the performance. If you look at during these times, okay, you have Pentium 1 comes, then Pentium 2, Pentium 3, Pentium 4, forgot, all kind of series. So with every release, Intel claimed that there is more performance. Okay, so transistor count was one thing, um, and then the performance increase was another. Okay, so if we look at this one, so this is our favorite two-dimensional transistor. Okay, so we have source,